guys, so hope you enjoyed the first part of the video. Now that video covered pretty much running in the spindle. I wanted to make sure that we didn't get any excessive heat in the bearings or anything like that before we went forward with the lathe. So in the second part we're going to cover the gearbox and probably make some chips, or we are going to make some chips. So, but I want to go over a couple things that came up in the first video that not sure if I covered it in the second part or not. But one is the biggest question, or the biggest thing is this a fixed speed on the spindle? Well, it is. You can't change the belt. It's always going to drive off of the large diameter pulley. I have the counter shaft, and if you remember, we talked about it in one of the other videos about using the counter shaft, and I decided not to. One, this thing would be another 1.5 or 2 foot taller, because it would actually have the motor mounted on the top, and then the counter shaft, and then pulleys to the spindle. I'm sure I can get by with what I have here. I do have a VFD. I've considered putting it on, and if I do, I may change this gearbox out to the other gearbox with a more modern motor, and it should drive fine. Next thing that came up was the belt wandering a little bit. Yeah, it wanders. I'm going to do some work on that, try to figure that out, and not sure it's going to come up in a video, but give me some time and I will. Now, when I made that first video, you got to remember, that was the first time that I ran it. So all of these issues hadn't been there. So I didn't know about them. I was trying to show you real time, first time run, and that's what you got. Even when we cut the material, it's first time. So I could have sit here and made all the adjustments, got it all running good, and then come in and let you see it. And I might, some people may want that, but I wanted to show you the first time it actually ran. The next thing was this bar. Well, I've covered this in the second part of the video, but this bar, and the more I look at it and think about how this thing ran, you got to remember, first time for me running it too, so I knew how things were working, but I wasn't sure exactly how to use them, if that makes sense. Well, this bar, what it does, it shifts the gearbox in and out. There is a double cone pulley, or cone gear, inside of that housing right there underneath the spindle. And it's a forward and a reverse. And it reverses the carriage forward, and then you have the forward on the carriage. And you can see that in one of the other videos where I actually took the lathe apart. But you got to think about it. When these guys were running these machines, these were line shaft machines, and most of the time, if you know on line shaft, you have a idler pulley, or a loose pulley and a tight pulley, or a clutch, and usually they have a lever to engage and disengage the feeds. I mean, not the feeds, but the drive. Well, the more I think about this, I'm not sure what these holes are for, but it may have something to do with the same thing. It may have been a lever that went up in the ceiling of the line shaft, come back down, and you can put control this with a lever, or they can reach across. I mean, I don't know, or maybe they had something that stuck out here. I don't know. If anybody has any idea, I'd appreciate it. But this black rod that everybody likes or wants to talk about is the shifter. There's nothing on like a modern lathe that shifts and reverses feeds. Some of them are over here on the tails, around the headstock. Some of them are on the carriage. This one is behind the lathe, and it's not very inconvenient to use. I mean, it's I'm standing 10 inches away from the lathe, and I can reach it fine to shift back and forth. So that's what this black rod is for. And like I said, I think I covered that in the second part of the video. I know I did. The gearbox. This gearbox and this mount, these things were designed in the 30s. The Lima drives started in around in somewhere in the 30s, and they specifically built these gearboxes to run these types of machines. These machines were line shafts were phasing out. Everybody was going to electric power, standalone motors, and you still had all this equipment. Actually, they were still building. I know Hendy was building cone head machines in the late 20s. So you had these machines around, and they needed a way to power them because, like I said, line shafts were disappearing. Guys or companies big companies were buying more modern machines, and these machines were trickling down to the smaller shops. Kind of like, smaller machine shops, or it could have been a small machine shop that invested a lot of money at the time and bought a machine like this, and they seemed to where they needed to power it by electric motor. Anyway, Lima developed these drives for this reason. It's a 4-speed drive. We have 4 speeds on the cone pulley, but this took the place of the countershaft, basically. The next thing is, the question was, I only showed 4 speeds. Well, the back gear works, and I actually have it in back gear right now, and I'm going to go turn on the phase converter, and we'll start it up, and I'll run it through the gears and back gear and let you see what it's doing. So stand by. All right, guys, so here we have it. Right now we got it in, let's see, if you pull out and pull over, we got it in low. This is the lowest speed it'll run. I calculated it out to be, I said this back gear was 10-to-1. I actually looked it up in the specs, and it's 9.1-to-1. And I think this is going to end up being about 12 RPM. I'm not going to put a piece of tape on here and check it again, but we can later. But this is why I didn't really want to put the tape here, is because there are going to be 2 different speeds. And the way the back gear works is it transfers this power through another set of gears in the back of the lathe back up to a gear set that's underneath this cover right here and drives this pulley. So, like I said, the lowest speed that this lathe will run is going to be, with the 9.1 calculated out, I think it's going to be 12.5 RPM. So stand by. Actually, that's the highest speed the back gear will run. So, all right, so you got the highest speed. If you shift over, this is going to be, let's see, this is going to be 3rd gear. This is the 2nd highest speed. And you can see, this is barely turning. Then if you pull out, or push in, that's where I had it wrong, I was pulling out. All right, this is 2nd gear in back gear. Okay. The low speed, like I said, around 12 RPM. Now the original lathe was set up to run, I looked that up also, set up to run 7. So we're almost 50% or 100, double the speed of the original one at the lowest speed. Honestly, other than maybe doing the relieving attachment, I don't know what I'll ever use 7 or 12 RPM for, but we got it. So here we go. You know what? Put it back in 4th gear again. Pull out 1st gear. Alright, so there we go. Can you imagine how much torque that is? When you got a 4-to-1 reduction in here, 4-to-1 here, and 9.1 to there. So total reduction, well, you're going from 1200 RPM to 12 RPM. You got a 100-to-1 reduction. So there you have it. The back gear is fine. Okay. So the next thing, like I said, the next part of the video is coming up is part I shot with, hold on, let me turn off this converter. Alright guys, so just wanted to, the next part of the video that's coming up was shot all the other day when the part that you've seen was shot. It was just a lot of video to cover. And mainly we just made some chips at the end of it. You'll see it at the end. We're making some chips, and it's just a piece of rod. And we're going to, I was proud of that. So I'm going to let you go to the next video. And what my plans are is in the next few days, or the next time you see this lathe, I'm going to actually make a part. I'm trying to find out what I want to make. We're going to run this lathe. We're going to tune it up. We need to still set the tailstock and the centers up where it'll make a good part. So anyway, I hope you enjoy the next part of the video. I know the sound is not the greatest when we're running a lathe, cutting the chips, making the showing it's cutting, and I apologize for that. I've gone through so much audio equipment in here trying to find the good stuff. Nothing seems to work good with everything. So like I said, I apologize for that, and I hope you enjoy it, and I'll come back after that part of the video and close this out. Alright, well, thank you for watching. We ran the lathe through its paces as far as the spindle goes. I think we had our total rise of about 10 degrees, and most of that was in the high speed. So now what we're going to do, we're going to look at the gear train. Alright guys, if you hear a hum in the background, that's my phase converter. It's just right on the other side of the wall there, and you usually can't hear it from the other machines, but this machine's you might can. Alright, so this machine's got let's get into it a little bit. This has got a quick change gearbox, and it will thread from 1.5 threads per inch to 88 threads per inch. So you got a wide range. You got you have your feeds, and depending on your gear set, you can feed from, maybe I can figure out this thing. You got some really fine feeds, like thought I saw one that was down in the thousands. But it looks like you can feed from 2.5 thousandths all the way up to 224 thousandths, okay, per rev. That's a pretty coarse cut, 224 thousandths. And your gear set, like I said, you can go from 1.5 to 88 threads per inch. The change gears are located behind here. And I'm just going to leave this back, put this back on. And we're set up now, we're set up with a 40 and 80. So from 40 to 80, we can do from 6 threads all the way up to 88 threads, and from 1.5 thousandths per rev all the way up to 23 thousandths per rev. So we're in a good setup to keep the parts on this machine. So you don't know exactly where you're threading at, so we're going to do a little test in a minute and try to figure out where we set up. Next thing is, when I got this lathe, this was a big deal. There was a lot of questions asked what this was, and I didn't know. Had some good suggestions. Anything from the old timers that ran line shafts, always wanted to couldn't quite trust a lathe, so they wanted something that resembled a line shaft. But what this reverses your, it's basically your shifter. There isn't one on the front of the lathe like most lathes have to reverse the feeds. This is your shifter that reverses the feeds. It feeds into the chuck this way and out of the chuck this way. And you can hear the gears go in. And then there's a neutral in between. Okay, and on here on the handles, let's make sure you can see that. And so these are your clutches. You engage your clutches by tightening up the clutches on your, this is for your cross feed, this is for your longitudinal feed. Again, I'll touch back on the quick draw, and then you have a half nut. Now, you have to be careful with this half nut because you can engage the half nut and the feed at the same time, and that'll create a problem because they're two different ratios, and you end up breaking your half nuts. So you have to be careful. There's no lockout on this one like modern lathes have. So what we're going to do, we'll back up. We're going to start up the lathe and get it moving. I guess it would help if I put it in gear. So we're just going to start out in low gear again, just like we did before. So we pull out, shift back to the right. Okay? That should be playing with it. I've got the gears engaged. Alright, so we got it in neutral. I'm not sure what our feed is there. We're going to find out in a second though. But, like I said, this is your shifter that shifts it in your transmission in gear. So now the transmission's in gear. And I do need to take this off. So let me stop it. Alright guys, so we got the lathe in low gear, and we're going to gauge the feeds. If you watch down here, I've got the cover off of the change gears, and we're going to start up the change gears. So now, like I said, I don't know what I'm feeding. So it runs nice and smooth. You got two speeds here. This will take it out of here, and then you got a higher speed. So that's really getting it. So that's going to be close to your 21 thousandths. Okay. So then we can engage the longitudinal feed here. Okay. So we're traveling down the lathe. Now, how you work this? There's some shutoffs down here that will switch into neutral when the carriage reaches your point. So let's see. Let's set one of them up. Loosen it and slide it down. Tighten it back up. So when that reaches that point, reaches that shut-off point, it will stop the lathe. So we got it feeding. Stop me feeding, okay? So now you're reversing your feed and it should run the other direction. Again, it's nice and smooth. Everything's working good on it. You got the same mechanism over here. It will stop Alright, and this is also how you thread. When you're threading, you can set these up and it'll stop at a certain point. You reverse your carriage, come back in, and thread. Like I said, you can use your quick draw. You never have to dial in to zero. You can always maintain your zero and your stop. You got a micrometer stop here that you can adjust your stops at, and then you just feed in on your carriage for your thread. I don't think we're going to make it on that one. I think it's going to hit this handle before. Anyway, you get the idea. And you'll pull it out of gear. So that's one of the things it's going to take some getting used to. Alright, so let's stop it and shut it off. And what I'm going to do is I'm going to go get a micrometer, an indicator, and we're going to indicate here, and we're going to turn the spindle by hand 1 revolution, and we'll figure out what our feed is. So what we need to do is we're going to feed in that direction. Until it catches all its backlash out of it. Okay, there we go. We'll set our 0. Alright, and I'm going to make 1 full revolution, I think. Well, I said I was. Alright, so let's try that again. Okay. Make a mark. Got me a little persuader tool. We're going to make 1 revolution. And we're set on set on 0. We're going to make 1 revolution. Alright, and we fed about 16 thousandths. So what I'm going to do is we're going to run this in a minute and we're going to shift it down. At least we know where we're at. So right now we're set up with like a 16 thousandths feed. Alright, and if we shift it to low gear, let's do the same thing in the low speed. Set your 0. And there we're in about 5 thousandths feed, so that's really light feed. Alright guys, so now we know, you know what, I forgot to lubricate it, so let's turn it on and let's lubricate it. Because we're going to turn back on the lathe. I'm going to disengage the hand wheel. And we're going to shift it in the drive. And we're going to lubricate everything. This is gear load, not the spindle load. Almost put it in there. So here we are at the lathe. We got a piece of, I don't know, maybe 1.1/8 mystery steel chucked up. I hope there's a hole in it. I don't think it'll bother it though. Anyway, I'm kind of just centered best I could. We'll adjust it if we need to. Got a tool bit in. I ground. Just a simple regular ground with a little radius on it. Now the other end I ground with a good bit of back rake on it. We'll see how they do. What we're going to do now is we're going to come in here and we're going to face it off. And feeds and speeds wise, we're running. Let's see. We're going to put this thing in that high gear. We're going to run that in third gear here, which was 250 RPM or so. Okay, let's see if that works. Alright, I do want to do one thing. I want to slow it down just a little bit at 21 inches. That's a little bit much to start with. Alright, let's see if that's a little bit better. Let's check our feed, our longitudinal feed, or our cross feed. Okay, it's working. Alright, so let's come up and touch off. Shot you can get. We're going to touch off. Alright guys, first chips in 50 years. I'm just going to feed it by hand and get this irregularity out of it and check center. Looks like we're a little high. So what's cool about this lathe, this tool post, you're a little bit high. Can you see that? You're a little high, you just, instead of shimming everything, come up and rock it down just a little bit. Now this lantern don't have a rocker in it like most lanterns do. This is what you do. So let's try it out. Make a move here. let's take a bite off of it with some power feed on it. Chicken and chips. Square up a little bit. Alright, so here we go, guys. Let's touch off. Set our 0. All right. So we got to switch up these. Alright. So what we're going to do is we're going to feed in. Now this is taking off the side, so we're going to feed in 50 thousandths. We're going to take 100 thousandths off the diameter. Tell you what, let me get some oil. Okay? We're gonna go ahead and finish this pass up. A nice chip, got a good tool there. Alright, so let's back up. Let's back up, and so we went in 50, so we're taking 100, that's 50 off. Let's go to 100. This will be taking, when you get to that point, we'll be taking a 200 thousandths diameter. This is at 18 inches speed. Tell you what, let's slow that feed rate down. I don't like the sound of that. Alright, so let's go back over here. We're taking a little bit too heavy a feed. We're going back to about 6,000 feet. $200,000 off the diameter. Finish looks okay. I'm going to jack it up a little bit more. Alright. I'm reaching for handles, guys. Alright, so we're going to come in and touch off. We're sitting at 50. Let's go ahead and go back to 0, which would be 75 thousandths. So that's 150 off. $75,000 a side. Alright guys, I hope you enjoyed that part of the video. I was really excited about making the first chips, and actually here's the piece of material I was using. And if you want to look at it here a little closer, it's a great finish on it. I don't know if you can see it real well. I'll put my hand by there just to hope it makes a little difference. But anyway, I was surprised at how well this machine cut. Now, I played around with it a little more. That probably won't get shown on camera. I know it didn't get shown on camera. But I was able to I went all the way up to 125 thousandths a side on this lathe. And so that's taking a 1/4 inch off in one pass. And that's, to me, that's pretty good. I think it'd do a lot more. It didn't even, the machine wasn't even struggling. So I was just more concerned with not tearing anything up, so I didn't really push it farther than that, but we will. But still, 125 side, I don't know too many instances where I actually take that much off on a cut, so I'm proud of that. Cut great. The tool bit, we're cutting with high speed steel. That's primarily the tool that you're going to use with this lathe, because the speeds, the high speed is 450 RPMs. And in my opinion, 450 is a little lower than what I normally run on one of my newer lathes, but I shouldn't have a problem running 450. I should be able to make anything other than something maybe really, really small with carbide or something, so I hope you enjoyed it. I've really enjoyed working on it, and to me the lathe is finished. This needs to be fine-tuned and start making parts on it. I'm going to have to do something about making me some kind of a slide in and slide out chip tray where I can catch some of this oil. And right now I got pigs all over the floor, so that's coming up. We're going to dial in the tailstock. Get everything dialed in on this lathe, and we're going to make some parts and see how good of parts we can make on it. I got an idea for something that's pretty precise. Work on the belt. Really and truly, the belt's fine. It ain't hurting anything. It just doesn't look as good as it should as far as moving back and forth or wandering. But other than that, I got some ideas. We're gonna play with some ideas that people send in. I really appreciate the advice on everything. Other than that, good with it. I want to thank a few people. First, Charles Shandefeld out of Florida, out of Jacksonville, Florida area. Well, I think it's White House, Florida. He donated the 14-inch LeBlanc lathe for me to have this 1200 RPM lineman drive on of, and I really appreciate that. The motor mount, the drive. I mean, I was really dreading putting that thing that was made, that superstructure that was built for this lathe with the counter shafts and all that. I really dreaded putting that on in this shop. Now, I wanted to put a line shaft. I don't have the capacity to put a line shaft in here right now. Hopefully one day build a shop and I can do that, and then we can take all of this off and run it like it's supposed to. Secondly, Keith Rucker. Keith made the belt for me. I called him up one day during the week and asked him if he had the material, told him what size I needed, and then in a few days it was sitting here ready to go. And then all of you guys that watch, I really appreciate that. That keeps me motivated to do things like this. The next project's going to be, I think to me it's going to be even cooler. It's going to be a little more, the machine's not going to be quite in as good a shape as this one was when we started. Not sure if it's going to be the New Haven lathe or the shaper. I'm leaning towards the shaper, but I've had a couple people ask me about the New Haven, and we need to talk about the New Haven a little bit. But anyway, the next project is coming up really quick because I've been dying to get on one of them too. All my subscribers, all my new subscribers, thank you. Everyone that leaves a comment giving me advice or telling me, you know, motivating me, you know, keeping me going, I appreciate it. Thank you very much. You know, if it wasn't for you, wouldn't be doing this. So, with that said, oh, there's one more thing. There's a young man named Edward Sabowski. He's got his YouTube channel, and with the new YouTube policies, you know, he's not a partner yet. He's like at 350 or 330, I think, the last time I looked, subscribers. Guys, this is a 12-year-old kid that's got his own machine shop, and I've watched some of his videos, and the kid actually does a good job of what he's doing. So if y'all look him up, get over there and subscribe to him, watch some of his videos, give him some support. I'm going to make up a little package here, and I promised it to him a week or so ago, and I haven't got everything together. But anyway, get over there and support these people, this young man and others that are out there trying to provide entertainment and some education on what they're doing. So with that said, I'm going to wrap this video up. So long from the Backyard Machine Shop. Till next time.